Welcome everyone to this presentation on creating multi-user training apps in AR, VR, and Web 3D. My name is Chris Schultz. I'm a specialist solutions architect with AWS, and my focus is on augmented reality, virtual reality, and real-time 3D applications of AWS services. I think this should be a fun and interesting topic. So I'm anxious to get started and share with you some insights I have based on a project that I've worked on recently. So this presentation is really based on a presentation I gave at our recent AWS reInvent conference. I've modified it and expanded it slightly to fit the webinar form. So in the reInvent version, it was driven by a lot of audience participation and open dialogue. Obviously, that's a little harder to accommodate in a webinar. So this version will be focused a little bit more on the presentation side, but we'll still have plenty of time for you to ask questions at the end. So I realize many of you maybe have been enticed by this presentation for a number of different reasons. So the description of the presentation covered a lot of ground. So it mentioned augmented reality and virtual reality applied to training. It also specifically mentioned an AWS service called Amazon Sumerian, which is our service for creating immersive 3D content. And it talked about architecting real-time multi-user applications. So each of these topics could be a whole session unto itself. I'm going to cover a little bit about each one of them and dive deep into each one of them. But if there's something I don't cover about one of the topics you're most interested in, I will be providing some suggested follow-up resources for you to use afterwards, as well as my contact information if you have additional questions after this webinar. So let's dive in. We'll start by talking a little bit about Amazon Sumerian in case you aren't already familiar with that service. So Sumerian is our tool for creating immersive 3D web experiences that can be accessed in any web browser. You can think of Sumerian as a tool set that lets you build and deploy these experiences very easily. And these experiences can be consumed in really three different ways. One is as an interactive Web 3D experience that works through Chrome or Firefox on desktop or tablet or mobile device. It can also be experienced through a virtual reality headset, or as augmented reality, which superimposes the interactive content on top of the real world when you're viewing on your smartphone. With Sumerian, you can target any one of these modes of consuming the experience, or you can build experiences that target all three. And that's what I'm going to be showing you in the example that I'll be sharing in just a bit. If we look at the general content production pipeline, Sumerian has a lot of features and benefits that really make it stand out. So we wanted to make sure that Sumerian made it easy to create this type of 3D content. So literally, you can create Sumerian experiences with just a few minutes of work. The editor and the API and everything that makes these experiences work is all browser-based. So you don't have to install any tools locally. You just access them through your regular web browser. And within that editor that runs in your browser, we provide both a sort of visual metaphor for adding interactivity, as well as full programmatic access through JavaScript. So whether you're a programmer or a non-programmer, you'll be able to create the ideas you want to create in Sumerian. Another thing we do to make creation easy is we give you a library of starter assets and templates to work with, so you don't have to always create things from scratch. And a big part of the Sumerian story is really integration, as you might imagine, with any of our AWS services. So augmented and virtual reality applications really benefit from a variety of different services being integrated with them. In Sumerian specifically, we have special integrations for things like Lex, our chatbot service, which also offers natural language processing, or Poly, our text-to-speech service, or IoT for creating 3D visualizations of IoT data. But really, any of the AWS services that are available through the regular AWS JavaScript SDK can be used in Sumerian. And that's really opens up the possibility for even integrating third-party JavaScript libraries, because all of Sumerian just runs in the browser using regular web technologies. So you can incorporate third-party JavaScript libraries easily to integrate with any service that you want to use. And then the final piece of the value of Sumerian is that it makes delivery much easier than some of the other options for creating this type of AR and VR content. So it's multi-platform, just like any other web application. You don't have to compile specific builds for specific devices, which is a huge win. And deployment can be as easy as just clicking on a publish button to share your work with the world globally across our content delivery network. So those are some of the values and benefits that Sumerian offers. But really, to understand it, it's best to see it in action. And that's what we're going to really focus the rest of this presentation on. So, in my role as a specialist solutions architect, especially for emerging technologies like AR and VR, a lot of what I do is help customers not only understand how the technology itself works, but understand what is made possible by these technologies. So, I undertook a while ago a prototyping effort to demonstrate the value that AR and VR could apply to training scenarios. AR and VR are really powerful tools when it comes to training because there's a lot of studies that have shown the physicality and the spatial nature of AR and VR really increase retention of information, particularly if you're training about a physical topic. So I set out with a goal in building this prototype that I wanted to demonstrate to customers the art of the possible when it comes to applying AR, VR, and Web 3D to training. And the vision specifically for this demo was to leverage these web-based 3D AR and VR technologies to empower a domain expert of some sort. So this could be in an enterprise, it could be in an educational institution, someone who has some expertise they want to share. Give them the power to be able to lead live training sessions remotely with users or learners across the world very easily. And additionally, I wanted to make sure it also offered a low effort mechanism to persist that knowledge so that it became easily accessible as on demand training after the fact. There were a couple constraints I put on myself for this effort. One was that I limited it to a team of one, just myself, and I time boxed the effort to 2 weeks. Now, the reason I put these constraints on myself was I wanted to, A, show our customers just how much could be accomplished in a small amount of time with just one individual in using these technologies to bring an idea like this to life. And the other thing that time boxing gave me is it forced me to make certain design decisions quickly and sort of gave me a yardstick by which to measure those decisions. Would they help me achieve my goal quicker in the end? So let's take a look at the finished product. So as you might imagine, an AR, VR, and Web 3D experience has a lot of moving parts. So trying to demo it live over a webinar can be a little challenging. So what I've done is I've put together a video showing the whole experience working. I'll play that video, narrate over it, and potentially pause it here and there to emphasize a few points. So let's start with the view that a student sees if they're logging in from their smartphone to view the AR experience. So everything is protected by a user login. Once the student signs in, they can then place the virtual object that they're being trained on in their physical space. So here we see an industrial air compressor. It's been miniaturized to fit their space, but they have full access to the virtual machine. Now we'll look at what a student logging in from their desktop or their tablet would see. Similar login process, but this time the piece of equipment is in a virtual setting. The student still has complete control over their viewing angle and what part of the machine they're looking at any time. So this is fully interactive throughout the live training session. Now we'll look at the instructor logging in. We'll move the augmented reality view out of the way for now. So the instructor is actually in virtual reality. And if you look on the left at the student view, you'll notice that the instructor is represented as a little avatar, and all of the instructor's movements are mimicked by that avatar. So where the instructor is looking, where the instructor is positioned relative to the machine. In VR, some of the built-in features of Sumerian are it gives you controllers that you can use to interact with the VR world around you. It tracks your position in space. So all of that functionality is just built into Sumerian. You don't have to do anything custom to get that functionality. Another bit of functionality that's built in is the ability to move yourself greater distances in VR using a mechanism we call teleporting. So you point on the floor, pull the trigger on the controller, and it will zip you right to that location. So that's a pretty common interaction model for navigating in VR, and we've provided it for you so you don't have to build it yourself. Then I also added a custom implementation for VR, which lets me use the thumbstick to rotate my body by 45 degrees. Now, in VR, obviously, you can turn your body physically and it will respond. But if you're perhaps in a seated situation or in a small room, sometimes it's convenient to be able to have that sort of manipulation. So that's basic navigation in this application. Now let's actually start the training session. So in VR, we can have a lot of freedom to use spatiality in the way we design our user interface. What I've provided is a little tool palette that automatically reveals itself when the instructor rotates their wrist and then conceals itself when they turn their hand back. So this palette could have any number of tools. I've only implemented two just to sort of show a couple examples of what you might do. And the way you interact with those tools is you grab them by intersecting the blue sphere on the controller and pull the trigger on the side of the controller to grab that tool and pick it up. So we've picked up the laser pointer. This is one way the instructor can draw users' attention or students' attention as they're communicating information. So if you look at the student view on the left, you see it's completely in sync with what the instructor is pointing at. That laser pointer is what I call ephemeral data. So it's not recorded anywhere. It's only viewable in the live during the live stream of this training. But I wanted to be able to do some persistent data as well. And that's where these info pins come in. So if I grab an info pin, I can press a button on my controller and it starts listening to my voice and transcribing what I'm saying into text. That text then becomes a part of that info pin so it can be accessed at any time later. So once I've recorded my message or my annotation to be a part of that pin, I just let go of the pin and it stays wherever I put it. If you look at the student side, you see the pin appears when I release it into the world and disappears when I pick it back up again. So let's go ahead and place a few pins on this machine just to sort of show the whole process the instructor would go through during the lesson. There are going to be certain parts of this machine, because it's like 15 feet tall in the instructor's view, that the instructor can't reach. So this is virtual reality. We have complete control over the world. So I've provided a way to scale down that machine to make it easier to access with a couple buttons on my controller. So I just scale it down to a miniature size that's about waist high. And now I can easily reach every part of that machine to place the pins that I need to place. And then when I'm done, I can scale it back up. You'll notice the pins sort of stay a consistent scale while the machine itself changes its scale. And in the student side, the scale doesn't change. The student is always the one in control of their view of the experience. So that's the basics of the interaction, but there's one Easter egg I put in here that I'll show you just to show how you can get creative with navigation.
Jetpack engaged.
So this is a feature I call jetpack mode, which you can enable to allow you to actually levitate yourself to parts of the machine that you can't get to. You'll notice that I made a design accommodation here where while you're moving, your peripheral vision gets blurred and restricted. This is actually something that you need to pay attention to when designing VR experiences, is how to keep your users from feeling queasy when they're navigating VR. Teleportation is one really good solve for moving users in VR when they're queasy without getting queasy. That tunnel vision is another way. So here's that AR view again, since we didn't see it live. This is just to show that all of the same features you saw working in the student view on desktop are also working in the AR mode. So the laser pointer, the tracking of the domain expert, the placing of the pins, all of that can be viewed from the AR experience as well. And this view shows that those pins are actually interactive. So when the student touches one of the pins, it reveals that text that was dictated by the instructor. So this could be viewed during the live stream, or it could be viewed as an on-demand module afterwards. You could also imagine that that text could be automatically translated to other languages using an Amazon service, or that same metadata could be applied to an application for field service technicians, for example, where they have the actual piece of equipment in front of them, but those annotations get overlaid on top of the real piece of equipment to help them operate or repair or maintain that piece of equipment. So let's take a look at how this was built and walk through some of the architecture. So there were 5 primary services that I used to create this application. Of course, the first and the most visibly obvious is Sumerian. So Sumerian provided the 3D development tools that I needed to build the experience, as well as a way to deliver that VR content over the web to end users. I also used AWS AppSync, which provides a way to synchronize data across multiple connected clients. Now, that data synchronization can be asynchronous or it can be real time. And so I used it for sort of the real time multi user features in this application. It's also used to help make the persistent data, so those info pins, for example, possible. The actual place that metadata is being stored is in DynamoDB. So that's where our content data storage happens. And for user login or identity management, I'm using Amazon Cognito as the service to help power that. And then AWS Amplify isn't a service per se, it's more of a tool belt. It's a set of utilities for developers that reduces some of the heavy lifting you normally have to do when building and deploying web applications. And it provided an easy way for me to get my web hosting up and running. And it also provided all of that really great looking user interface for my user login. So let's look at how those pieces connect together. So starting with the users, when a user logs into the application, they're first going to access the URL via CloudFront, which is our content distribution network. Amazon Cognito is what's powering that user authentication piece. And once the user is authorized, they can see the full front-end application, which is hosted on Amazon S3. I built the front end as a React.js application. It's not a very complex front end because most of the functionality is actually built in Sumerian, but things like the user interface are delivered as React.js components. And then, of course, my Sumerian scene is embedded within that application. While the live training session is happening, Sumerian is talking to AppSync, which is handling all of the coordination between all the students and the instructor while they're connected. And then AppSync is persisting some of its data, like those info pins, to our DynamoDB database. Within AppSync itself, you define your API through something called a GraphQL schema. And I'll talk a little bit more in detail about what GraphQL is in a moment. And you also use something called resolvers, which simply tell AppSync how and where to store the data. Finally, as I mentioned, Amplify provided a tool set that I could use to really coordinate all of this infrastructure and connecting all of these components together. And it was super helpful in helping me meet that 2-week time frame. So there were a number of design decisions and challenges that I encountered along the way with a project like this. This is the point when I delivered this as a talk at reInvent, where we really opened it up for a lot of open discussion. What I've done here for our session today is taken some of the topics and ideas that came up during the reInvent session and chosen those to list here, and we'll focus on just the first 4 to dive a little bit more deeply in how these pieces were implemented and how they came into play. So we'll start with the user login. So When building this application, I was faced with a design choice, an architecture choice to make about how to support user login. So obviously, one choice I could have made would be to roll my own, to implement my own custom user login, which would have meant implementing a service on the back end to manage users and to do authentication, a database to store user information, and then the user interface on the front to make it all work. Or, as I chose to do, I could use Amplify combined with Cognito to give me that functionality in a much more easy way to implement. So to give you an idea of what easy means, Amplify, when you're using Amplify, one of the tools it provides is a command line interface for adding features and functionality to your web application. So I'm going to give you sort of a high-level view of what I did to add user login and user management functionality to my application. First, to add user login support to my web app, I just needed to execute this command line, which is amplify update auth. So this adds the configuration and the user interface components that are needed to support authentication. Then I executed amplify push, which takes care of setting up all my backend resources for me automatically. So I didn't have to go in and configure anything manually. In my JavaScript code for my application itself, I just had to change that first line to that second line to enable authentication. Now, I chose to do this app as a React app, but Amplify also supports Vue and Angular and a few other front-end application frameworks. So you have a lot of options there. And then finally, to share the application with the world, I just use Amplify Publish, which takes care of building my application and distributing it to all the right places so that it can be served up globally. So it really was this easy. There's a few more details in here that I've glossed over, but you can find all of those details in this Sumerian tutorial. So if you're interested in using Amplify with Sumerian or adding user login functionality to a Sumerian experience, this is a great place to start this tutorial. The next thing I want to touch on a little bit is building for reuse. So I do a lot of these demo applications and prototypes. And one thing that's important for me is that they not be one-off examples, but that they actually result in some sort of reusable elements that can help accelerate our customers when they're building their own projects. And so this project in particular resulted in a lot of reusable components. And that's because Sumerian actually has a great model for adding interactivity, which lends itself really well to designing in a reusable fashion. So within the Sumerian editor, any object you see in the virtual world is something we call an entity. So an entity just has a 3D position, a rotation. It's got a point in space that it lives, and most entities are visible. And you can make any of those entities interactive by adding scripts to them. The great thing about the way this is implemented in Sumerian is you drag and drop those scripts onto the entity itself, and you can combine multiple scripts. So a single entity might have many scripts attached to it. So this really encourages you to build small, focused, single-purpose scripts, which turns out is a great approach for creating reusable functionality. So what you see here is a screenshot of that info pin and the scripts that I had attached to it. You're not seeing the actual script code here. What you're seeing are the public sort of parameters that each script exposes to be able to customize that script's behavior. Here's what an actual script looks like. So this is one of those scripts on the info pin. It's not a very long script, but it's also not a trivial piece of code. So I don't want to have to write it multiple times. So it's really great that I could write it once and then reuse it across many different entities. Here's just a list of some of the reusable scripts that I ended up creating as a part of this project that I've now been able to reuse on other projects. I think these scripts are really useful in a variety of different contexts. So we're working to create an open source repository where we can share these scripts and others with customers, and also where the community at large can contribute new scripts for Sumerian. That isn't launched yet, but to be informed of when it does launch, I suggest signing up for our public Slack channel. And you'll find me on Slack as AWS-Chris, or you can always email me directly and I'll keep you informed of when those scripts launch as well. So let's look at one of the challenges I needed to solve as a part of this application. So it turns out that multi-user applications, especially ones that need to sort of reproduce real-time movement, can be a little bit tricky to implement. And game developers have struggled with this and solved this over the years. It's not a trivial problem. And the challenge here is that the updates that describe where any object is in the world, those are only happening at about 1 frame a second or 2 updates a second. But the application itself is probably running at 30 or 60 frames a second, or in the case of VR, maybe 90 frames a second. So if we only update the position of our elements when a new update comes in, it can look very jerky. So I'll show this video, which kind of demonstrates the before and after of the problem I was trying to solve. So this is the same application that you saw, but this is doing no compensation for those low frequency updates. So it looks very jerky and almost stop motion, the movement of the avatar. You'll see that the laser pointer is also kind of hard to follow because it jumps from location to location and isn't moving fluidly. This is because the updates are only coming in about once or twice a second. So I had to come up with a strategy that would make it look much smoother, as if we're getting updates 30 times a second or 60 times a second. So this is the end result of the solution I came up with. It's very fluid, very easy to follow. From an end user perspective, you don't necessarily realize that the updates are coming in at a very slow fashion. So how did I implement that? Well, it's easiest to illustrate this through a little bit of a sort of illustration series here. So imagine the white point on the grid here is the starting point of my avatar, that little head representing the instructor in the scene. And then I get a position update from the server that says the avatar has now moved to this new location in the 3D world. Instead of immediately moving my virtual object to that new location, what I do is I move it some fraction of the way in between those 2 points. I'm going to show it as moving halfway here just for simplicity, but it's actually a much smaller fraction in the actual implementation. So then that's the first frame update on the client side. So it's a rendering update, which is about 30 or 60 times a second. So then another frame update happens, and we still haven't gotten a new position update. So we apply the same algorithm. We'd move halfway toward our goal. Then another frame update happens, and the position still hasn't changed. So we move another halfway toward our goal. So we're getting closer and closer to our goal, but never quite reaching it. So it's sort of doing this smooth motion between the 2 points. Now let's say we do get a position update. It's maybe a second later than the original position update. And now a frame update happens, and we keep following that same pattern, keep moving halfway toward our goal. So with this approach, where you're always getting a little closer to your goal, the illusion is that we're getting much more frequent positional updates than we actually are. The resource I would point you to implement your own version of this is a part of our API docs that describe the tween move action. Now, this is a piece of code that won't necessarily do exactly what I'm describing, but it'll be the most important component you would use to implement an approach like I've shown. And if you have additional questions about how I implemented that, please feel free to ask. Okay, we'll move on to the final challenge that I wanted to talk through, and that was learning GraphQL. So as I mentioned, when using AppSync to control our real-time data synchronization, AppSync uses GraphQL as the way to define the API and the subscriptions and events that happen to make all that work. GraphQL was something that was new to me when I started this project, and I found it a little challenging at first to know where to start. What my first instinct was to look at the AppSync documentation itself and look for clues there. But it turns out the AppSync documentation sort of assumes you already know the basics of GraphQL and just talks about the pieces of how you apply it in AppSync. What I ended up finding to be an excellent learning resource was the graphql.org website itself. They've got a lot of great information, and they even have an interactive tutorial that you can do in browser that teaches you how to write and use GraphQL. And they break it down with very simple examples. So this is a great place to start. To get an idea of what GraphQL actually looks like, I wanted to show you the GraphQL I created for this particular application. So I've already talked about entities in Sumerian being sort of the core building block of these visual elements. So in GraphQL, you create data types that describe any information that you want to share between your connected clients. So obviously, one of the most important data types in Sumerian is an entity. So I described an entity with just 5 properties here. So as I mentioned previously, every entity has a position in space. So that's represented by this translation property. It has a rotation, which tells what direction it's pointing. So that's represented by this rotation property. And every entity also has a unique ID, which is what this instance name is. The other 2 properties here, parent name, so entities can be nested inside of other entities. So the parent name just tells which other entity this entity may be nested under. And then entity type was a custom property I created just to describe, for example, whether this entity represented one of those info pins or whether it represented the instructor's VR avatar or some other element in our Sumerian scene. So with just these 5 pieces of information, we're able to describe to all the connected clients any changes that are occurring in the application. A little bit about GraphQL here. So it's a very declarative kind of language for defining your APIs. What this is saying is that instance name is a string, and the exclamation point indicates that it's a required. So whenever you get an entity object from AppSync, it will always have an instance name. Contrast that with parent name, which is also a string but has no exclamation point. So that indicates it's an optional value that may or may not be there when you get an entity reference. And then, of course, as you might guess from the translation and rotation properties, the square bracket indicates that it's an array of float values, an array of numbers. We don't have to talk much about the laser pointer. It was just sort of a specialized version of entity. So really, there were only 2 data types I had to define for this experience. And for many Sumerian experiences, you would only need to define this one entity data type. So in addition to your data types, you also describe any queries that can be run against your data. In my case, it was just a single query. It was this get entities query, which returns an array of entities. So this is used when my scene first starts up to know which, for example, how many info pins there are already in the scene and where they should be displayed. Again, it's very declarative. You don't see implementation details. You just see a description of what the query is called and what it returns. The other thing we can define is mutations, which are things that change our data. So this is very familiar to most any type of application. We have a way to add new entities, remove entities, or update entities. So very simple. The indications here explain what data is required to make that mutation. So to add an entity, we need all 5 properties to be provided. And what it returns is a copy of that entity. To remove an entity, we only need the instance name, for example. And finally, subscriptions. So this is really where that real-time piece comes in. So your GraphQL schema can define these named subscriptions, you can think of them as events or messages that connected clients can subscribe to know when a change happens. So for example, I have an entity added subscription, which will always return an entity. And the trigger for that is anytime the add entity mutation is called. So if let's say my instructor version of the application releases one of those, he grabs one of those info pins and releases it into the world, it calls the add entity mutation, and then all of the connected clients receive this entity added subscription message. So very easy. Again, it's all declarative. And then finally, you just bundle all this up into a schema. So you say that my query is represented by that previous query block I shared, mutation by the mutation block, and subscription by the subscription block. When you put it all together, it looks like this. So it's very succinct. It's not a lot of code. Any of the logic about how this is actually implemented is done by those resolvers I mentioned. And in AppSync, we provide a bunch of pre-built resolvers, which you can choose to, for example, persist this to a DynamoDB database. If you're interested in more specific details about implementing multi-user functionality in Sumerian, we have a tutorial focused specifically on that. So it uses a lot of the same technologies I've talked about. So definitely check that out. And at this time, I'd like to open it up for any of your questions. I've also included my contact information on here. Feel free to reach out to me. Again, Slack is a great way to get a hold of me. I also would encourage you to check out our YouTube channel, which has a lot of training and tutorial videos you can follow to get started in Sumerian or to learn about specific topics very easily. And you'll also see us appear quite often on the